get page 7980 out. I'm not going to collect it today because I want to make sure you have the bottom part down. But
I have a question.
I'm going to go over it. What's your question?
Oh, but did you want us to do G and H?
No, those are the bottom questions, right?
Yeah.
No, we're going to cover them. All right, so just taking a look at page 7980. Does everyone feel comfortable for each and every one of them, 1 through 6, the domain is negative to positive infinity?
Yes.
The nice thing is, for every parabola we work on in this class, unless it's bound on a word problem, will be negative to positive infinity for the domain. That should be easy. But then, let's start hitting the range. And I'm going to go through the range on each of them. So remember, the range is, what is it doing in the y direction? Okay? So, let's see. I'm going to list the, so for problem 1, it appears the vertex is, oh shoot, I can't see it. -2, -5. Problem number 2, the vertex is at 0, 0. Number 3, the vertex is at 1, 0. So I'm just listing all the vertexes, which I guess that's answer E, but it'll help us. Problem number 4, the vertex appears to be at 1, 4, -1, 4. And number 5, the vertex is at 0, 3. And problem 6, the vertex is at, oh shoot, that's blurry. 1, 2, 3, 4, 4, -1. Okay. So, so I guess those would be the answers for letter E on all of them. Yeah. Right? Because I just found the vertex for all of them. Is that okay? And I'm just going to put that this one, I'm going to have this one opens up. Number 2 opens down. Number 3 opens up. I'm just kind of making a little mental note so in the red so we can look at it. 4 is down. 5 is up. 6 is up. Okay. So if your parabola opens up, your domain, or excuse me, your range will start at a number and go to infinity. If your parabola opens down, it comes from negative infinity, it comes from the bottom up, so it comes from negative infinity up to the top. So when we're looking at the range, remember the range is the y value. Agree? So this is a y value. These are all y values. The y value of my vertex is going to dictate the range. It's also knowing the direction it opens. So being this one opens up, if I take the elevator up, the range starts at -5 and it goes to infinity because it continues to go up.
Now, what is that called?
That's the range. So all this purple we'll call the range. Okay, and I'll do the range over here too. Mm-hmm. Yeah.
So if it's up, would it be negative?
So all of the domains for all of our parabolas that are problems like this, that aren't word problems, the domain will go from negative to positive infinity every time. Yep. Still the same exact thing. But if it's a word problem, that's where we'll start bounding it. And I'm going to show you today where it's going to bound a little bit, okay? But we're just looking at the range. So again, the range is what it's doing in the vertical direction, okay? Now, this one opens down. So if I'm coming up, I'm coming from negative infinity, and I'm going up to 0. Okay, the graph will go above 0 in the y direction, but it came from negative infinity. Number 3 opens up, so it's going to come from 0, because that's the y component of the vertex, and go to infinity. This one opens down, so it's going to go from negative infinity for the range up to 4, square bracket. This one opens up, so it starts at 3 and goes to infinity. This one opens up, so it starts at -1, square bracket, excuse me, and goes to infinity. That's all it is. It's like, what's the graph doing in the vertical direction? Being the graph of a parabola, the starting point and the end point will both be pointing up or they'll both be pointing down, will allow you to figure out one region's not bounded means it goes forever, either to negative infinity or positive infinity. But that's how we do the range of those. Okay? So now let's talk about max and min. Max and min deal with the y component as well. Okay? If the parabola opens up, is the vertex at the lowest point or the highest point if the parabola opens up? The parabola opens up. Where's the vertex? At the highest point or the lowest point? Lowest point. Okay? So this right here is a min. The y component again. So the y component has all kinds of features it deals with. Okay? Problem number 2, the parabola opens down. Is the vertex at the highest point or the lowest point if it opens down? Highest point. So 0, right here, the y component of this is a max. Whoa, hey, stop. Okay? Is that all right so far? So, number 3, the parabola opens up. So is the vertex the highest point or lowest point? Lowest point. So this is a min. That 0 is a min. Number 4, parabola opens down. Is the vertex at the highest or the lowest point? Highest point. So this is a max. Parabola opens up. Vertex at the highest or the lowest point? Lowest. It opens up. Vertex is down at the bottom, right? So that's a min. Parabola opens up. Lowest point. That's also a min. Okay.
Have any problems where it's not a max or min?
See, the vertex is either the max or the min. The y component of the vertex is either the max or the min. We won't deal with any parabolas that open sideways. They do exist, but we're not going to deal with it in this class. Okay? So the roots on these problems, if you can see definitely where it crosses the x-axis, then you label that point. If you can't see where it crosses, if it just crosses somewhere in between like 0 and 1 or 5 and 7 or 5 and 6 or something like that, then you're just going to put that as irrational. So none of these we don't see the equation, so we can't go and factor it. So if you were to look at your parabola and it was on an xy grid, if your parabola looked like this, so I could probably tell what that point is pretty easily. Do you agree? I mean, I could say, hey, my root is 1, 0. But here, if I'm just looking at the picture, I can't really see. I know it's between -2 and -3, but I can't see exactly where it's at, so I don't need to list it. So when it crosses exactly at a point, and you don't have the equation given to you, then you just list that as the root. This root would probably be irrational. Now, it might be a rational root, meaning it might have crossed truly at -2.5. But when you're looking at a picture, unless it's a finely tuned, really exact graph where you had multiple lines in there, I wouldn't expect you to know that that's -2.5. I'd expect you to know it's between -2 and -3. But does that make sense? So if you look at your root set of any of your problems, like problem 1, they appear to be irrational. Problem number 2, my roots would be just one of them at 0, 0. Problem number 3, it's only one root that happens at 1, 0. Okay, kisses it. Number 4, your roots appear to happen at 1, 0 and -3, 0. Number 5 doesn't have any roots. Why do I say that? You put your phone away. It doesn't cross the x-axis. No roots. They're actually called complex roots, but we'll get there later.
That's what I wrote.
Good. And then number 6, it looks like it crosses at 3, 0 and 5, 0. Right. Put it away, all the way away, please. All right.
I wrote doesn't cross the x-axis,
I like it.
but it does.
Is everyone okay finding the axis of symmetry? It's always x equals and the x component of the vertex. That's it. There's not any more to that. X equals whatever the x component of the vertex is. So if your vertex was like 2, 7, your axis of symmetry is x equals 2. So it's means a vertical line. Okay? And then interval where it's increasing and decreasing. Okay, so this is the last thing I want to talk about. This doesn't really relate to any of the problems. But let's talk about this. Let's say I have some parabola that looks like this. So all I know is my A value is positive on this and it opens up, right? So, did it ask where it's increasing? Okay. So, I want to know where our graph is increasing. Where will it increase? Okay? This goes back to when we're talking about slopes. An increasing slope is a positive slope. A decreasing slope is a negative slope. So if my vertex was right here, this whole region right here is increasing. That whole region right there is increasing. That's all it means. That region there is increasing. Now, you could then define a decreasing or an increasing graph if this is my vertex, which is in x comma y as a point. This graph is increasing from x, my x component, and going to infinity. So why do you think I have a rounded bracket at the x?
Because it goes
What do you think?
all the way.
Because it's like just one number. It's not like
It's one number. Hey, thank you. Not here. Can you sign
There
it?
you go.
No, sure. Anyone else wants me to sign it? So, my question is, why is this a parenthesis right there? Okay, so let's see.
Because
Yeah.
it stops at
Okay.
a line.
Okay, you're kind of on it. So, if I were to find the slope from here to here, this is negative, 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 negative. And then over here, this is positive, 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 positive. What is it right there?
Negative,
No.
positive.
It's not undefined, it's the other one.
Oh, it's 0.
It's 0. So a horizontal line has a slope of 0. So if this is a negative or it's decreasing, when it gets right here, it's not increasing or decreasing, it's just 0. And then it starts back up. That's why it's a rounded bracket. So that's sometimes a tougher concept to think about.
Mr. Shrift,
Yeah.
how do you know that that side's increasing but that other side isn't?
Okay, so if I were to take 2 points anywhere on this side, and if I were to find the slope between those 2 points, literally using our slope equation from linear equations, my slope from here to here will be a positive slope.
I see you.
The other side would be a negative slope. So the slope over here is negative. So all over here is decreasing up to this point. It's 0 at this point, and all the way up here is increasing. So the slope, and the slope that, we've been dealing with slope equation for a long time. If you take 2 points and you find the slope and you show that it is negative, you have a decreasing function at that region. If you have 2 points that you find, and here's the hard thing. A lot of students will say, but it's not a straight line between those. You're right. But all we're doing is looking for the average rate of change between 2 points. In order to find the average rate of change means you have to find the slope. And that's what that means. Now the very last part says, where is it positive?
Increasing
No, letter H.
of
We already took care of the increasing.
x where f at x is positive.
Okay. So here's positive. This is the only portions that'll be positive up here. That's positive. Why is that positive? What does it mean if I say it's positive? It's above the x-axis, exactly right. Okay? So let's just label here. This is some smiley face, frowny face point. Agree? And this is some smiley face, frowny face point. Why am I using those? Well, because I don't know what they are. I'm just identifying them. So it's positive. If I want to know where the whole thing is positive, it's in the x direction coming from negative infinity out this way until I get to that point right there, which is smiley face, the x component of it. Where is it positive over here? It's positive. So it's above the x-axis from smiley face to infinity, because as they go this way forever. And that's a bigger concept, but that's where we're at with this so far. Is that okay? All right. I know I didn't ask you to do page 81, but I think let's use a little critical thinking on page 81. Let's take a look at it. Number 7. It says a rancher is building a rectangular corral for her horses. She can afford to build 300 feet of fencing. A lot of times if you buy fencing, they charge you by the foot. Okay? So they'll say, okay, 6-foot fence costs this much per foot. A 4-foot fence will cost this much per foot. And that's just your perimeter of your fence. So she wants to make this rectangular corral for the horsies. Okay? So that means that if I were to find the whole perimeter of this, she can afford 300 feet. Does that make sense? So it could be a square to a rectangle and anywhere in between. There's a certain limit that takes place. Well, if you look at the parabola that's drawn, it does this. So this point right here is 0, 0. And this point down here is 150, comma 0. Okay? Why do I not deal with anything in the negative direction as far as this graph goes? Yeah, it's not negative dollars. You're not making a negative length of a fence, right? So this is one where, and it's not asking for it, but this is one where our domain would go from 0 up to 150. And they'd probably be rounded brackets at each because if I had a width of 0, that doesn't make sense that I made a fence that had of a rectangle had a width of 0. If I had a width of 150, that also wouldn't make sense because I can only afford 300 feet of fence. That means that if I had a width of 150, another width of 150, now it's 300. I don't have any other dimension. Okay, so this is one where our domain will take place. Now there's this point right here, which they say is 75 comma, what's the other part? 75 comma what? 5625?
Yep.
Okay. And they say that this is the area. How do I find area of a shape? Length times width as far as a rectangle. And this is the width. They're calling this the width. Okay? So, this forms a parabola. At the vertex, if I were to make my corral that had a width of 75, that would give me an area of 5,625. That is the maximum area that corral could have. Okay? So if I had made this side 75 and this side 75, well, that means that has to be 75 and 75. How do I know that? 75 plus 75 is 150. 75 plus 75 is 150. 150 plus 150 is 300. So in this case, she has to make a square corral, and a square is a type of rectangle, but that would give her maximum area of her horse corral. But then there's one last point that's on there. It's like kind of there, and they say that that is 30, 3600. So that means that if you had made your corral 30, a width of 30, you would have a maximum area of 3,600. So if this is 30 and that's 30, well, that's 60. That gives me another 240. So that means it has to be 120, 120. Okay? So in order for this person to have the maximum area, is it possible somebody has a piece of property that's larger than the area that they're going to fence in? So this is this case scenario. Not everyone has a fence along their property line. Some people have a different area that's fenced in. If you can only afford up to a certain amount, you can create your maximum area by doing this type of math. Okay? So I want to leave those for now. I just want to leave those for now. But those are definitely great types of questions for you. Hang on to that homework, and I'll probably spot check it by Thursday this week and put the points in for you, okay?
Okay. It's so cold. 3 days until spring. Really? How's your car?
Car got towed to the shop now. Yeah, I think it's the alternator. I think.
Wait, how many days? Like before. Okay, so if seniors get out in 33 days, how many days do we get out?
43.
40. They get out in 10.
Cool, thank you.
No problem.
Oh, you're good. Don't you worry. I'm glad it's done. I'll get that graded. While I'm doing this, you guys grab your homework, pass on the rest. Anyone who's not here, just recycle it. Okay. So I want to look at this very first problem for a moment. X squared minus 4x plus 3. Okay? We have a lot of information we've worked with parabolas, quadratics, okay, second degree polynomials. So I want to walk through this a little bit. I want to show you something that's just pretty dang amazing. So yesterday, we found the vertex, and then we did a number to the right of the vertex and a number to the left, which would be the same. And then we did a number to the right of that number and a number to the left of that number, which gave us the same, because we know that a parabola has symmetry, right? Meaning the axis of symmetry, that vertical line that's in there, if I folded it over on top of itself, it would work. Is that okay? So let's kind of walk through this in a couple of fashions. Does this parabola open up or down? Up. Does everyone feel comfortable? It's going to look something like that? Okay. I could probably come over here and identify my A value being 1, my B value being -4, my C value being 3. That'd probably work. Yeah.
How do you figure out if it's opening up or down?
The A value is a positive number. Okay. Could be any positive number you want. As long as it's positive, it'll open up. Doesn't matter if all the rest is negative. That A value is positive, up all day long.
What the A value is, regardless of square root.
Yep. All right. We good so far? Yeah, because the A value is right here. There's a 1 that sits right there.
Yeah.
That's what the A value is. The x squared doesn't affect the A value.
Yeah.
Okay? All right. So things how you could approach this problem. Some of you might see that this could be factored, and I'll just factor it quickly to be x minus 3, x minus 1. Okay, so this one could be factored. I'm not going to walk through our factoring steps. I just saw it could be factored. So this is going to yield me x equals 3 and x equals 1, which this yields me the point 3 comma 0. This yields me the point 1 comma 0. Okay, so I'm kind of leaving the factoring idea. I'm not going back to the magic number, going through the whole spiel, going, what are the factors of 1 and 3? And you guys sit there looking at me going, 7, 12, no, 3, 18. These numbers coming from? So again, if you don't know how to factor, you need to come see me. If you don't come see me, you'll see me again next year in the same class. Okay, and I'm not saying that to be mean. I'm saying that, trust me, if you can't get through factoring, it's not going to work. All right, so I'm going to plot 1, 0 and 3, 0.
So we have the roots.
We have the roots because we factored it. Hey, what do you think will guarantee happen in between those 2 points right now?
The line of symmetry.
Line of symmetry, the axis of symmetry.
Or yeah, the
Okay, so guaranteed right here, in between these 2 points, is our axis of symmetry. Now, what sometimes gets tough, x equals 2, right? X equals is a vertical line. What gets tough is that axis of symmetry is used as a guide, but it actually isn't part of the parabola picture. Okay, it's just that imaginary, that's why I make it a dotted line. Okay, it's the imaginary line in between. What else do you think might happen between 1 and 3 on this thing?
A curve.
A curve. What do you got?
The vertex.
The vertex is definitely going to happen in between those 2. So my vertex is going to happen at 2, something.
but then you plug in 2 for all that.
Yeah, I plug 2 in, so I get 2 squared, that's 4. 4 minus, or negative 4, that's negative 8, plus 3. So if I add that together, I get to negative 1. So at 2, negative 1, I have my vertex. Now, I did indeed show you this yesterday, that x equals negative b over 2a is the equation that finds us the axis of symmetry, but it also finds us the x component of the vertex. So let's verify this. Okay, so I have negative, what's b? Negative 4 over 2, what's a? 1. What's negative 4? Positive 4. What's 4 over 2? Does that match up to that vertex? So there's logical thinking. Negative b over 2a is a really valuable tool, but we saw real quick that this factored real quick. All right. You ready for what I think is probably the coolest thing that happens in math? Okay. So we're going to use the foundation of 135. Got it? 135. 135. Okay? That 135 is related to our a value. If our a value is 1, we're going to graph using 135. Still with me? Is my a value 1?
Yes.
Okay, ready? Watch this. Put your pencils down, just watch. All right. This is my vertex. With me still? So the 135 pattern graph means if our a value is equal to 1, 135 is going to work. So that would mean right 1, up 1, left 1, up 1. Yes, we already had those points identified. Agree? Okay, my next value is 3. So I'm going to go from this point, I'm going to go out 1 and up 1, 2, 3. I'm going to go 1, 2, 3. What do you think I would do from these points? I'm going to go right 1 and up 1, 2, 3, 4, 5. And this one, left 1, up 1, 2, 3, 4, 5. Here's my parabola. Can I identify what these points are? Yeah, that's 1, 3. That's 0, 3.
So you can do it with even alpha roots. So you can graph it with just the vertex.
That's exactly right. So let's move to let's go to the very bottom problem on that page. What is it? Y equals what?
X squared.
Plus what? Plus 15? Oh, cool. Okay. Everyone's good. This opens up. A value's 1. If a value's 1, 135 is going to work really well for our pattern graphing. So the only thing I need to find right now, this is so cool. I'm so happy you guys are going to see this. Oh, this is such an amazing thing. Yay. All right. My A value is 1. My B value is -8. My C value is 15. Still with me? We just learned that, or the other day, that negative b over 2a is the x component of our vertex. It's also our axis of symmetry. Yes? Okay? So I'm going to plug right in. So I get negative 8 over 2 times 1. What's negative 8? Positive 8. What's 8 over 2 times 1? 4. So I'm going to get a vertex at 4, comma, we have to plug it back in and figure it out. So this is going to be my vertex. Ready? 4 squared is what? 16 minus 8 times 4. 32 plus 15. Well, if I add 16 and 15 together, I get 31, and negative 1. So 4, 1, 2, 3, 4, negative 1. Vertex. Axis of symmetry. Yes? Pattern graph. Ready? Pattern graph with 1, 3, 5 will work because our a value is 1 right now. Still with me? Ready? Ready? Right 1, up 1. Left 1, up 1. Oh shoot, what did I just find?
Oh my gosh.
Found the roots. How do I know it's the roots? It's on the x-axis. Okay? Ready? I'm going to go right 1 and up 3. And I'm going to go left 1 up 3. And I could keep going to 5, but I'm going to be off my grid.
Let's go higher than 5. You just
1, 3, 5, 7, 9. It's all odd numbers.
Wait, how do you get 1, 3, 5?
Okay? It's how a parabola works. Okay? So, you're so awesome to ask that. You ready?
It's not even that. I'm just like really confused.
No, watch. Ready? If I were to find the slope of those 2 points, the slope, still with me?
Yeah.
So that's the point 4 comma negative 1. Agree? That's the point 1, 2, 3, 4, 5 comma 0. Agree? If I label this x1, y1, and x2, y2, and I use my slope equation, which is this, y2 minus y1, oh shoot, over x2 minus x1. So I'm going to go, my slope is 0 minus 1 over 5 minus 4. So that's plus. So that's 1 over 1. That happens. If I were to find the slope between here and here, it's going to go up 3, right 1. And if I go from here, it's going to go up 5, right 1. And from here, up 7, right 1. Now, some of you are asking, what about the slope over here? So you remember it's symmetric. So the pattern's working over here, but you know that this point has to be in conjunction with this point. This point has to be in conjunction with this point because of how a parabola works. Yeah?
What about the negative 8?
Well, I'm not worried about that. You know what this 15 is? 0 comma 15 is where it crosses here. Way up here.
So this one works with the 8. So what about
For right now. Turn the page. Go to the page that has the one at the very bottom blacked out. You with me? Pick one of those that has a positive a value and shout it out to me.
y equals 2x squared?
Uh-huh. What's it?
4 plus 6.
4x plus 6, like that? Is that right?
Oh no, not 4x.
There's no
just 6.
It's just what?
We probably X.
It's a, oh, it should be a 4x. I think they made a mistake on it. So write in an x in there. I'm sorry about that. Okay. Now, things that might be sticking out is I have a GCF of 2 on all of these. They could be factored, and that's all great. Does this parabola open up? Why? The a value is positive. Okay. Let's see if I can grab some real quick. Let's see if this is going to work. That looks like a good one. Will you let me copy image? Will you let me paste image? Yes.
It worked.
Love when things like that work.
Me too.
Sweet. Gosh, today's just
Gosh,
good day
darn.
for you, Mr. Scrub.
Hey, I'll take it. All right. All right. Ready?
Ready?
Okay. What? I don't know if I want to have the numbers on there. I have a grid that doesn't have the numbers on there. I'm gonna use that one. No, I don't want that one. I want one that have numbers. There we go. No, that's got numbers. Give me one that have numbers.
Oh, there's one.
I want it bigger than that though. How about that one? Oh yeah. Copy. Delete. Paste. And I'm gonna copy that so I can use it again. All right. Ready? Move over a smidge. All right. Hey, what's my A value? A value. 2. B value. C value. Okay. Now we're not using the C value yet, but we will. I just want you to be good at it. And the equation that finds between the x component of the vertex as well as the axis of symmetry is what? Negative b over 2a. Negative b over 2a. Still with me? All right, let's plug our values in. So I get negative 4 over 2 times 2, which gives me negative 1. Do you agree? So my vertex is at negative 1 comma something. Right? So let's do a little bit of math. Let's figure out the y component. If I plug negative 1 in right there, that's negative 1 squared, which is 1. 1 times 2 is 2, okay? All right, 4 times negative 1, negative 4, and 6. If I add those together, let's see, that's 8, 4, negative 1, 4. Still with me? Oh, it is. Oh, you guys are good. Oh, shoot. All right, negative 1, 4, negative 1, 1, 2, 3. Yeah, but they started confused because they're always off a smidge. And it's like, blah. So, does everyone feel good about that? All right, ready? You remember the 1, 3, 5 that we just talked about?
Yes.
And we're only really using the 1 and the 3 because the 5 kind of goes off our screen. Still with me on that?
Yeah.
Okay. So the 1, 3, 5 is related to my A value. What's my A value? 2. So it's actually going to be 2, 6, 10 now.
What?
So it's basically multiplication, you double it?
So if that A value was a 3, it would be 3, 9, 15.
Oh my gosh.
If it was a 600, it would be 600, 1800, 3000.
Say what?
So you take whatever your A value is, in this case 2, and we're going to double 1, 3, 5 to 2, 6, 10. Ready? Right 1 up 2. Left 1 up 2. Right 1 up 6. 1, 2, 3, 4, 5, 6. Left 1 up 6. Hey, can I see? Do I know what my axis of symmetry is real quick?
Yeah.
Yeah, my axis of symmetry is x equals negative 1. It's this. Right? Holy cow. Oh, you want to know about the negative numbers. Thank you for asking. We're going to talk about that right now. All right. Let's go back to the very first page. Still with me? Go back to that first page. Let me paste. Yay, still working. Let's go back to that first page. Find me one of them that has a negative x squared. I don't care which one it is, but let's have an A, B, and C value.
Oh, the last one.
Is there any of them that has a negative x squared?
The last one.
Just normal negative.
Oh, none of them. Oh, I guess we have to do y equals negative x squared.
Plus 4.
Is it plus 4? Yeah, plus 4. All right. Hey, what value am I missing up there? Huh? A b value, right? The b value is attached to x. So if I were to use my x equals negative b over 2a, what can you guarantee is my x component? What can you guarantee is my x component of my vertex? 0, right? The x component of my vertex is 0. Why is that? Well, I have negative b. Well, my b value is 0, so negative 0 is 0. 0 on top gives me what for an answer? 0. All right, so let's plug 0 in. 0 squared, 0. Negative 0, 0. 0 added 4, 4. There's my vertex. 1, 2, 3, 4. This is going to open down, yes? How do we know? Negative. Now remember I just said the 1, 3, 5, right? Goes along with the a value? Yes? So what do you think?
Negative 1, negative 3.
Uh-huh. Okay, ready? Right 1 down 1. Left 1 down 1. Right 1 down 3. Oh, I found a root. Left 1 down 3. Oh, this is big enough. Right 1 down 5. Left 1 down 5. There's my parabola. There's my axis of symmetry. There's my roots. Holy shnikes, this totally works. Pattern graphing. Guys and girls, pattern graphing is like the greatest thing with parabolas. It works on all of them as long as you realize the 1, 3, 5 and it's 1, 3, 5, 7, 9. It goes on forever. Forever and ever and ever. Huh? Not yet. Not yet. Well, the b value finds you part of the x component of the vertex, right? We will get to the c value, but I'm just been labeling all the way through. All right. Let's have you. Okay, we're going to do this. You know, I gave you this big old packet of notes, and guess what I didn't do? Because I like mine way better. I'm sorry. 83 and 84. But you know what I want you to work on? 84. Okay? Try that pattern graphing. Guys and girls, you got to find the vertex first. Label your A, B, and C. Find the vertex. Use negative x or negative b. X equals negative b over 2a. The x component, plug it back in. Find the vertex. Once you find the vertex, your pattern graphing works with the 1, 3, 5. Realize that relates to your a value. Try it, try it, try it. See if you can get it. 84 right now is fine. Cool.